Every time I use a cloud AI assistant, there is one question sitting in the back of my mind: where is my data actually going? I'm not just talking about random questions. I'm talking about source code, business documents, meeting recordings, private notes, unfinished ideas, client information, and all the other things that I would never casually upload to a public website. The good news is that we have reached a point where you can build an almost completely private AI workspace on your own computer or home server. You can run the language model locally, chat with your documents, search the web without building an advertising profile, automate tasks, write code, transcribe audio, generate images, and even access the whole system remotely. And you can build most of it using 12 GitHub repositories. Now, I want to make something clear before we start. I'm not saying you need to install all 12 projects tonight. Some of them overlap, and some are alternatives. Think of this as a toolbox. You choose the pieces that match your hardware, your workflow, and how private you actually need the system to be. The first repository I would start with is Ollama. Ollama is probably the easiest way to start running open models locally. Instead of manually downloading model files, configuring inference engines, and remembering complicated commands, I can install Ollama, run a command such as Ollama run, choose a model, and start chatting. It also exposes a local REST API, which means other applications can use the model running on my computer. That makes Ollama more than a chat program. It becomes the local AI engine behind the rest of the workspace. I could connect it to a web interface, a document assistant, an automation system, or even my own applications, as long as I select a model that fits inside my available RAM or VRAM. The prompts and responses can stay on my machine, but Ollama is designed to make local AI convenient. Sometimes I want more control, and that brings me to the second repository, llama.cpp. Llama.cpp is one of the most important projects in local AI because it makes it possible to run language models efficiently across a huge range of hardware. It supports CPU inference, GPU acceleration, quantized GUF models, and multiple hardware backends. It can run on a powerful workstation, but it can also run smaller models on a laptop, a mini PC, or certain edge devices. I think of Ollama as the convenient package manager and service layer, while llama.cpp is the engine room. Most beginners should probably start with Ollama, but when I need specific quantization settings, detailed performance tuning, unusual hardware support, or direct control over the model server, llama.cpp gives me far more flexibility. The third repository is OpenWebUI. Running a model in a terminal is fun for about 10 minutes. After that, I want something that feels like a real AI product. OpenWebUI gives me a polished, self-hosted interface that can connect to Ollama and other OpenAI compatible APIs. It supports conversations, model switching, user accounts, document retrieval, tools, and other features that make a local model feel much closer to a complete online assistant. It is specifically designed to support self-hosted and offline deployments. This is usually the interface I would expose to people inside my network. They do not need to understand Docker, model formats, context windows, or inference commands. They open a browser, choose a model, and start working. The fourth repository is AnythingLLM. At first, AnythingLLM may look similar to OpenWebUI, but I see it as more focused on structured workspaces, document collections, retrieval, and agents. I can create separate workspaces for different projects, import documents, connect a local model, and ask questions against a specific body of information. It also includes document pipelines, vector database support, agent features, and multi-user controls. For example, I could create one workspace for product research, another for legal documents, another for my YouTube scripts, and another for a software project. Each workspace can have its own files and context instead of throwing everything into one giant database. The self-hosted version is designed so that documents, chat histories, settings, and embeddings stay on infrastructure controlled by the user. It can also operate in an air-gapped environment when it is connected only to local models and local storage. Personally, I would not automatically install both OpenWebUI and AnythingLLM. I would test them and decide which workflow I prefer. OpenWebUI makes a great general AI portal. AnythingLLM can be especially useful when documents and project-specific knowledge are the center of the system. But uploading a PDF into an AI tool does not automatically mean the AI understands that PDF properly. This is where the fifth repository, Docling, becomes extremely useful. Docling is a document processing system originally started by a team at IBM Research. It can parse PDFs, Word documents, PowerPoint files, spreadsheets, HTML, images, audio, email files, and several other formats. More importantly, It tries to preserve structure, such as reading order, tables, page layouts, formulas, and code blocks. That matters because a bad document parser can quietly destroy the quality of a RAG system. Imagine a financial report with 3 columns and several tables. A basic text extractor may mix the columns together, detach numbers from their labels, and feed complete nonsense into the model. Docling is designed to turn complex documents into cleaner, structured data before they enter the AI pipeline. It can run locally, including in sensitive or air-gapped environments, so the original files do not need to be sent to a cloud parsing service. Once those documents have been processed, I need somewhere to store and search their meaning. That is the job of the 6th repository, Qdrant. Qdrant is a vector database written in Rust. Instead of only searching for exact keywords, it can store embeddings and retrieve information based on semantic similarity. It supports dense vectors, sparse vectors, multiple vectors, metadata filtering, and hybrid search. In normal language, that means I can ask a question using different words from the original document and still retrieve the relevant section. Docling prepares the document. An embedding model converts its chunks into vectors. Qdrant stores those vectors. Then my local language model uses the retrieved information to answer the question. That combination is the foundation of a serious private knowledge system. The 7th repository is SearXNG. A private AI assistant becomes much less useful when it cannot access current information, but giving an agent direct access to a normal search engine can expose queries, IP addresses, and behavioral data. SearXNG is a self-hosted meta-search engine. It gathers results from multiple search services while avoiding the normal user tracking and profiling associated with many search platforms. I can connect SearXNG to WebUI, an agent, or an automation pipeline, and give my local model a controlled search tool. There is an important distinction here. The language model may still run locally, but the search requests must reach external search providers. So this is not the same as being completely offline. It is better described as privacy, controlled web access. If I need a truly air-gapped system, I would disable web search entirely and limit the assistant to local files and databases. The 8th repository is N8N. A chatbot answers questions. A workspace should also perform work. N8N is a self-hostable workflow automation platform with visual nodes, code support, AI integrations, approval steps, and connections to a huge number of external services. It can connect local models to files, databases, webhooks, email systems, calendars, APIs, and internal business tools. For example, I could build a workflow that watches a folder for new documents, sends them through Docling, creates embeddings, stores those embeddings in Qdrant, and then makes the information searchable inside my AI interface. I could also create a workflow that transcribes a meeting, produces a summary, extracts action items, and saves everything to a local project folder. One detail worth knowing is that N8N describes itself as fair code and source available rather than using a traditional fully permissive open source license. For personal self-hosting and internal workflows, it is still extremely useful, but businesses should understand the license before building a commercial product around it. The 9th repository is Tabby. If part of my workspace involves software development, I do not necessarily want every unfinished function, API key mistake, internal repository, or proprietary algorithm sent to a cloud coding assistant. Tabby is a self-hosted AI coding assistant designed as an on-premises alternative to services such as GitHub Copilot. It provides an open API interface, editor integrations, repository context, and support for consumer-grade GPUs. I can run Tabby on my own machine or server and connect it to my development environment. That gives me code completion and AI-assisted development, while keeping the codebase under my control. Of course, the actual quality depends heavily on the coding model I choose. A tiny model will not magically outperform the best cloud systems, but for autocomplete private repository questions, repetitive code generation, and internal development, a local coding assistant can already be surprisingly practical. The 10th repository is whisper.cpp. Typing is not always the best way to interact with an AI system. Sometimes I want to record an idea, transcribe a meeting, dictate a document, or speak directly to an assistant. Whisper.cpp is a lightweight C and CC implementation of OpenAI's Whisper speech recognition model. It can run locally across Windows, macOS, Linux, mobile devices, browsers, and even relatively small hardware. It also includes examples for microphone streaming and offline voice assistant applications. Instead of uploading a confidential meeting recording to a transcription website, I can process the audio locally, generate a transcript, pass it into my document pipeline, and let my local model summarize it. This is where the separate repositories begin to feel like one real system. The 11th repository is ComfyUI. A complete AI workspace should not be limited to text. ComfyUI is a node-based interface and backend for building local generative media workflows. It can run image generation, image editing, upscaling, controlnet pipelines, and increasingly complex video, audio, and 3D workflows, depending on the models and custom nodes I install. The node graph can look intimidating at first, but it also gives me an enormous amount of control. I can build one repeatable workflow for thumbnails, another for product images, another for background removal, and another for generating variations from a fixed visual style. And because the models can run locally, private reference images do not automatically leave my machine. Just remember that custom nodes are code. I would not install random community extensions without checking who maintains them and what they do. The 12th and final repository is Headscale. This one is not an AI model, but it solves a problem that appears the moment I want to use my private workspace outside my house or office. The easiest but worst solution would be to expose OpenWebUI, N8N, Qdrant, and my other services directly to the public internet. That creates a security nightmare. Headscale is a self-hosted implementation of the Tailscale control server. It lets me create a private WireGuard-based overlay network connecting my devices without publicly exposing every internal AI service. That means I can leave the AI workstation at home, connect from my laptop while traveling, and access the services through a private network. But I want to emphasize something: self-hosted does not automatically mean secure. I still need strong authentication, encrypted connections, backups, operating system updates, restricted ports, safe container configurations, and careful control over which tools my agents are allowed to use. A local model with unrestricted file access can delete private data locally just as easily as a cloud agent can damage cloud data. Privacy and security are related, but they are not the same thing. So, if I were building this from scratch, I would begin with only 3 components: Ollama for running the model, OpenWebUI or AnythingLLM for the interface, and Docling for processing documents. Once that works, I would add Qdrant for a larger knowledge base, SearXNG for controlled search, N8N for automation, Tabby for coding, whisper.cpp for voice, ComfyUI for visual generation, and Headscale for remote access. llama.cpp would be there when I need deeper control over inference. The final result is not just a local chatbot. It is a private AI environment that can read, search, write, code, listen, create, automate, and connect to my own information without requiring every task to pass through someone else's server. It will not always be as easy as paying for one cloud subscription. I have to manage models, hardware, updates, storage, permissions, and backups myself. But that is the trade. Cloud AI gives me convenience. A self-hosted AI workspace gives me control. And when the data includes my private documents, my source code, my recordings, my ideas, and possibly the entire knowledge base of a company, control may be worth far more than convenience.